Hello everyone, in this video I'm going to talk about how you can manage your pipelines in GitLab. I assume that you've been working with pipelines and have some basic knowledge about jobs and the whole platform, which is GitLab. I've also created posts and short videos for purpose of this presentation. You'll find the links at the end of the presentation. I want to talk about 4 keywords which are very useful in creating pipelines. And after that, I will show some examples. The keywords are include, extends, rules, and trigger. The first keyword, include. There are 4 types of includes. As the name suggests, with this guy, you can include other YAML files to your gitlab-ci.yml. So it's very useful when your config grows and grows. You can split it into more files and then include them. And there are 4 types of include: local, file, remote, and template. With local, you can include a file from the local repository. It must be on the same branch, of course. So you can put the logic behind the jobs into separate files. Here's an example. You can keep each job in another file and then include them in gitlab-ci YAML. Here we include our jobs from YAML files from configs catalog. Here's the file type. With this type, you can get access to private projects on the same GitLab instance, so you can include files from other projects. It's useful when your projects are very similar and setup looks almost the same. Then you can just include one template file. If you have microservices, you can create a template and then include this file in every repository with microservice. So here we want to include microservice YAML file from a CI setup project from master branch. And you have to remember that everything is evaluated during pipeline creation. So if you change something, you have to create a new pipeline if you want to see your changes. Another type is remote, and with this you can include a remote file. The file must be accessible by GitLab instance. And the last type is the template. With this you can include templates which are shipped with GitLab, but I haven't used it yet, so I can't say anything practical about it. And that's it about include keyword. With this, as you could see, you can easily split your large file into smaller ones, and it's very useful when your projects are similar. Then you can create a template and include it in these projects. Next keyword, extends. With this, you can inherit from other jobs, mostly from hidden jobs. And here's the first example. We have 1 hidden job and 2 deploy jobs. Both of them inherit from the hidden job. And in deploy prod job, we want to run this job manually. So you can see that you can override everything what you inherit. After pipeline creation, we'll have 2 jobs, deploy dev and deploy prod. And because we want to run the same script in every job, but one of them is manual, we can use extends keyword and inherit the common logic from hidden job. Here's another example. We have 2 jobs, test and second test. In the first one, we have 2 sections, before script and script. In the second one, we inherit from the first job, but we add another after script section. So after pipeline creation, we'll also have 2 jobs, and they will look like this. The second job is almost the same as the first, but we added after script section. If we want, we can also override before script section, for example. Here's one important thing about inheriting. You can merge hashes, but not arrays. In this example, we have 2 jobs. In the first one, we set 1 variable. In the second job, we inherit from the first job, but we add another variable, my second var with value 49, into variables section. The output will be this. Because variables section is a hash, we can just merge this hash. So in the second job, we have 2 variables in the variables section. According to GitLab documentation, the algorithm used for merge is closest scope wins. So case from the last member always override anything defined on other levels. So we can inherit something and then overwrite what you want, but we can't merge arrays. Here's an example. In the first job, we have 2 comments in script section, and in the second job, we want to inherit from the first one, but we change the script section and we can't merge arrays. So what will be the output of this operation? After pipeline creation, the output of the second example job will be this. The script section has been overwritten. You can't merge arrays. You always override them. So you must be careful here. For such cases, you can always use before or after script sections if you want to add something to the list of commands. Next keyword, rules. With this, you can include or exclude jobs in pipelines. This keyword replaces only except keywords. You can't use both rules and only except keywords in the same job. And using rules, you can provide 2 attributes: when and allow failure. Rules are evaluated in order until the first match. When matched, the job is either included or excluded from the pipeline. In this job, we have 2 rules. If the pipeline is created on master branch, then the first rule evaluates to true and we spawn the job. We also changed when keyword from default on success to always. So we always spawn the job on master. And if you push your changes on, let's say, develop branch, the first rule evaluates to false. So we go to another rule because we don't check anything in this rule. It always evaluates to true. So we can treat it as a default rule. Then the job is manual and it can fail. Within the rules, you can use these clauses. If statement is self-explanatory, I think. With changes, you can check if files have been changed, and exists checks if there are specific files. I've shown you an example with if before, so let's check other clauses. One of them is changes. Using this keyword, it's possible to create or hide a job based on an array of files or catalogs. In this example, we want to run this job only when something has been changed in Docker file or app catalog. So if there is no change or change is only in readme file, for example, then the job will not be spawned. Another keyword is exists. It's similar to changes keyword. It evaluates to true when there is a such file. So in this example, the job will be created if there is Docker file. You can mix these clauses, so you can use all of them within one rule. In this example, the first rule checks if it's a master branch and if there is a change in Docker file. So if you push your code on master and there is a change in Docker file, then the job will be spawned. If you push something on master branch, but there is no change in Docker file, then the first rule evaluates to false and we go to the second rule, the default one, and the job will be manual. Next keyword, trigger. With this keyword, you can define a downstream pipeline trigger. There are 2 types of downstream pipelines. With the first type, you can trigger a pipeline in another project. And with the second type, you can trigger child sub pipelines, but in the same project. Here's an example of a trigger job. You have to set a path, the project, and optionally, you can provide the name of the branch and you can choose strategy. By default, the trigger job doesn't wait for the downstream pipeline to complete. It completes with the success status as soon as the downstream pipeline is created. So if you want to wait for the downstream pipeline, you must set the strategy keyword to depend. This way, the trigger job will behave like a normal job. And in this example, we want to trigger pipeline in my project repository on master branch, and we want to wait for this pipeline. In child pipelines, you need to use include keyword. So you can include files from the same repository or from another one. You can also use strategy keyword as in multi-project pipelines. Using child pipelines is useful when your pipeline is complex and you want to split it into sub-pipelines. For example, if you have many jobs with tests and you don't want to show them in a pipeline, you can run them as a child pipeline. Let's see some more advanced examples. In this example, let's say that we have many microservices. They are written in the same language and we want to build an image, test it, and then deploy the service. So we can create a template file in a different repository and then include it in every microservice project. So on the left, we have an example of the template file, and on the right, we include this file in every microservice. You have to remember that you can always overwrite what you want, as you can see on the right column where we overwrite repo variable. If you don't have tests in some projects, you can always overwrite the script section in test job and print some info like please add tests, for instance. Here's an example of extends keyword. We have two jobs. We inherit from the deploy job, and for each job we change the env variable. And for the prod, we want to run this job manually. And after the deployment to production, we want to send some info on Slack, for instance. And here's the last example. Let's say that we have our microservices, and because we have a lot of them, we want to deploy them from one place instead of clicking on each deploy job in every repository. So we can create a repository from which we want to trigger deploy jobs. In trigger project, we can create a pipeline with manual jobs which are responsible for triggering pipelines in our microservices. We also use the extends keyword. We want to spawn a pipeline in specific project on master branch, and we want to wait for this pipeline. So by clicking on trigger job, we will spawn a new pipeline in a specific project. But here's one problem. We will spawn a whole pipeline, but we only want to deploy the specific service. So we can fix it using rules keyword in microservices pipelines. In our microservices, we can add rules section. In build job, if pipeline is created by triggering it, the first if, in the rules section, we'll evaluate to true. And because we set when to never, the job won't be spawned. Additionally, we want to build the image automatically on master or developer branch. The second rule. Otherwise, the job should be manual, the last rule. And the deploy job should be always spawned if the pipeline is triggered on master branch, the first rule. If it's not triggered, but it's a master branch, the job should be manual, second rule. And otherwise, we want to hide this job, the last rule. So this way, in our mother repository, clicking on trigger job for a specific project, we will trigger a pipeline in this project, but in this pipeline, we will only see a deploy job. And that's the end of the presentation. I showed you how you can manage your pipelines using these 4 keywords, and I hope that it was useful. There are some QR codes and links to my blog posts and YouTube videos, so if you want to see more examples, please use them.